we are very pleased to have this opportunity to present our current work that we are developing in Guadalajara lab. And we have divided the presentation into 3 sections. We are going to start talking regarding this invitation you have received some days before, which concerns to this event that we are organizing at the University of Guadalajara, but this time the lab has been invited by our rector, our principal, to take the lead in organizing this event, which is HABITAT LATAM. And in the second part, we are going to present 2 ongoing projects that we are developing with the lab and with one of our students from the master's degree in City Science. And at the end, I will give you a quick update of our collaborations within the network and also with the network of the IDB, the International Development Bank. And well, we are going to start, and I will hand it over to our General Director, Sergio Roldán, whom some of you may have already know him in the previous presentation we had with the network. I don't remember if it was with BioBio, I think. And also to Monica Gomez. They are going to introduce this event, the HABITAT LATAM, for this year, 2025. So I don't know if it's Sergio starting or Monica.
I know.
Yeah.
Good morning, everybody. I think that Monica is a better the English for mine. Moni, if you like,
okay,
have a presentation of the Science Lab Guadalajara, please.
Yes, thank you. Next one, please. So hello, everyone. I always have my script. So welcome to HABITAT LATAM. This event is about cities that feel. It will be in Guadalajara on August 25, 26, and 27. This meeting brings together people from all over Latin America and the Caribbean to talk about the future of our cities. We want to make our cities better for everyone. Next one, please. So here you can see a photo from a previous event. Many people came together, government, universities, companies, and community organizations, but mostly government. This shows that HABITAT LATAM is for everyone, but mostly with government. Next, please. So HABITAT LATAM is not something new. We have been working for several years, since 2020. This timeline shows meetings and agreements in Mexico, Chile, the United States, Egypt, Poland, and more. And these steps help us build an urban agenda for Latin America. We believe in teamwork and in thinking long term. Next, please. So before this event was organized by Mexican government, especially the Ministry of SEDATU, the Ministry of Urban Development. But now, for the first time, the City Science Lab at the University of Guadalajara is leading the event. This is very important to us. So we want to show what city science means for us. City science is about seeing cities as complex systems that we call socio-eco-technical systems. Next, please. So it means working together, government, universities, industry, and society. Only with everyone involved can we really change cities. We see the city as a place where everything is connected and everyone is important. So HABITAT LATAM uses an integrated approach. We work with 3 main dimensions: social, ecological, and technological. And we also involve 4 key groups: academia, government, industry, and civil society. The most important ideas and actions happens when all these groups work together. So next, please. So this is the structure of the main event. The event is organized around these three big topics. So each day we will have sessions that focus on these three dimensions, and we want every topic to be seen from different points of view, social environment, and technical stuff. Now, next, please. And every days, all groups are present: academia, civil society, industry, and government in each panel. This way, we make sure that every proposal and solution is built with everyone's perspective. This is how really city transformation happens, we think. Next, please. And now we are invited to you. Here you can see the program for the 3 days. We have sessions about social, ecological, and technological topics with experts from many countries. Like, you know, guys, Boston, Hamburg, Andorra, Taipei, Israel. So Bio Bio and Guipúzcoa, Shanghai. Here you can see this program, and this shows that HABITAT LATAM is international, and not just in the Latin America side. We want to learn from everyone, and also we want to show that we're doing here in the global south. No, I guess that's it for the program.
Okay. I will take the mic. Thank you very much. I will start working about one of the two ongoing projects that are being developed at the laboratory. First of all, hello everyone. My name is Gama. I think some of you know me, and the project is the conceptual framework to model urban mobility under stress during mass events, AKI, urban mobility under stress. The intention of this presentation is to introduce some initial ideas behind the research project, as well as the supporting theory. This is not a theoretical nor a technical presentation, but just wanted to present the key ideas behind. Just wanted to mention first that involved people at this very first step is Felipe Rivera, who is a student from the Master of City Science program of the University of Guadalajara, who is also going to be presenting some parts of this presentation. Also, Mayra Gamboa and I are part of this project. Yeah, I want to start with a quick context. I just wanted to say that traffic, everybody suffers traffic. Traffic is a complex phenomenon present in cities, which is caused by a variety of reasons. For example, many people going home after a long work day, people attending a concert, or, for example, a massive sporting event, among others. These situations are what we call the stressors of the infrastructure. No matter the origin of the traffic, it is a symptom of the demand of mobility infrastructure not being satisfied. You know, if we follow that approach, we can imagine traffic as the result of a process of clients, the cars, not being satisfied by a server, the crossroads or the semaphores, with a service, which is the service is using the transit route. Actually, it is possible to use modeling tools coming from the network science and mathematics to obtain information about expected performance of the road under high demand conditions. And this is actually what motivates this project. We have a main research problem, which is how we can better understand and mitigate urban traffic congestion, especially under stress from massive events. But following this approach of applying some engineering tools and mathematical tools to to try to understand what are the key points of that stressors, what are the main reasons, and also what are some of the ideal solutions for that problem. No? The main objective is the creation of a network-based model of urban traffic flow using queuing theory to simulate and analyze congestion, particularly during high demand scenarios. And the hypothesis is that modeling urban mobility through queuing networks, that Felipe is going to present something about that concept, that will reveal critical points and will permit finding an infrastructure configuration that results in optimized mobility during high demand situations. This project is based in 3 big steps, which is called the methodology. The first one involves the use of special syntax used, the special syntax, space syntax model that I think some of you guys already know, which is a kind of model that tries to characterize the network of roads, no? In order to get some KPIs, for example, what are the weakest nodes of the network in terms of traffic. With this approach, we can get some hotspots or some key areas of interest in which we would like to focus on in order to study and to solve traffic in an area. So that is the first step of this project. This is a kind of characterization, a kind of conceptualization to understand better the network of roads in a city. Taking that as a base, the second step is applying the concept of service and servers and apply that to the study of traffic. In this part, we will try to understand the roads network as a network of queues or as a network of services, and we will try to conceptualize people moving through the city as the client. So we want to optimize that. We want to find cases in which the configuration of the road network gets shows the best results in terms of a number of people waiting to be served, or number of people who is queued in a traffic jam. Also, for example, how much time is expected for a person traversing the road of networks to spend in that traffic jams in different situations, especially in under high demand scenarios. And finally, the step 3 is actually taking this conceptual model and implementing a simulation model in which we will try to see some other aspects of that scenarios, and see what happens if we move one of other part of the network infrastructure, because there are some events during the week, or for example here in Mexico on Sundays we have the Vía Recreativa, which is a program in which some of the roads are closed in order to enable people on bikes or just running to make use of the infrastructure or part of the infrastructure. So that kind of events is what we want to simulate here. So, and yeah, that is a quick overview of the methodology, and I will give the mic to Felipe, who is going to present some other aspects of this methodology.
Thank you so much, Gabo. Yeah, thank you so much. So my name is Felipe Rivera. I'm a student of the Master of City Science. And yes, nice to meet you, and it's a pleasure for me to be here. I'm going to start checking some concepts that we are going to use for this research, for this project. The first one is the queuing theory and the queues network. The intention of this is we want to use, or we want to yeah, we want to use the QE theory and qubit networks in order to explain the way the network streets and the vehicles works as a queues network. For example, we are going to use the clients, or the nodes will be the vehicles, and the intersection and semaphores will be the servers. So we want to have this structure as a queue network, and we want to make some measures in the way the nodes or the vehicles are served for the clients in the intersection. We want to identify some critical nodes in order to create the model that Gamma explained. Yep. So the application, as I mentioned, the application to the traffic is the vehicles are the customers or the nodes, and the intersection are the servers. So as you can see in the image, we want to translate, or we want to use these queue networks using queue theory, and we want to translate the avenues and the streets and the intersections into a queue networks. So next slide, please. This is one of the concepts that we want to use, and also we want to use a space syntax. A space syntax is a set of analytical tools that will help us to understand the spatial layout and the movement and accessibility in the cities. For example, we want to use this to create a preview diagnosis of our current infrastructure. I mean, here in Guadalajara, we have many venues like stadiums or some other theaters and we want to create a preview diagnosis to see how central or how betweenness is our structure. For the space syntax, the centrality it's a measure and how connected a place is. For example, if a place it's in the center, it has a lot of connection. A lot of people can walk there, or vehicles can drive there, and it's very connected. And also we want to explore the betweenness, and it's to identify the key pathways that the people use to go to that place. For example, shortcuts or something like that. So those are the two concepts that we want to use to build this model. Next slide, please. And what are we expecting with this, and which impact would have this model? So the first one is to identify areas in the network. So we want to see if we have some vulnerability in some node or intersection. And also we want to have some quantitative metrics on the congestions under normal and stressed condition. A normal condition is the day-to-day, how the traffic is working in the day-to-day. And also we want to have some metrics and what happens if we introduce a stress condition like a sport event or a concert in a specific area in the city. And also we want to see the actual or the current configuration. How is this affecting how is this affecting the traffic, the current configuration and the streets and the avenues we have in the city? And with the impact, we want the impact we are trying to have with this project is, at first, we want to inform urban planning and event management. For example, Guadalajara will be a venue for the next World Cup. So maybe this model will help us to have some metrics about how is the traffic around the stadium that will be a venue for the next World Cup. And also we want to enhance the understanding of how social phenomena impact the urban mobility. Those are the impacts that we are planning to create with this project. So I think the next slide is for you, Gamma. Thank you.
Yeah, thank you, Felipe. I don't want to take too much more time. Just wanted to speak a bit more about the next steps. As this is a step, as this is a project that is in a very initial step. The next thing that we are going to be working on is the creation of a network-based model to study city mobility. We first want to describe or characterize a case study, as Felipe mentioned. We have the idea to use one of the massive events that are going to be organizing the next year here in Mexico, which is the Soccer World Cup. And this involves a massive validation step guided by a massive number of data, of information. So in order to achieve that, we are planning to push the data collection, which is actually what connects this project to the next project that we are presenting today, who is in charge of Alejandro Lepe. So yeah, I think that's it for this project particularly. If you have any questions, please let us know at the end of the presentation. Yeah, thank you. Please go ahead, Lepe.
Thank you. Hi, my name is Alejandro Lepe. I am an urban planner, and today we are presenting our project, the Urban Dynamics Detection and Analysis System. Through this system, we aim to transfer the way they understand to manage our cities using cutting-edge technology to capture the pulse of urban life now. Next, please. These projects, the purpose is to develop and implement an urban perception system based of artificial vision and distributed sensor nodes for real-time capture, analysis, and visualization of mobility and environment dynamics. The objective is to generate geospatial intelligence and feed digital twins that serve as precision tools for urban planning, infrastructure management, and evidence-based decision-making. It's important. This project is a collaborative effort between the Uniterra, the University Real Estate Agency, Cutonalá, Cutlajomulco, and Cusey University Centers. Next, please. Our work is based on global frameworks, specifically the Sustainable Development Goals, geospatial roadmap. This diagram illustrates how a robust system integrates different data inputs, both geospatial and statistical. These inputs are processed according to the key principles, such as interoperability and accessibility, and are supported by key elements like standard and infrastructure. The result is a series of high value odds, ranging from harmonized information to tools for decision making. Our system is designed to execute this flow in a practical and efficient manner. Next, please. Now let's see how we implement these frameworks on technical level. Our architecture is divided into three phases. Input, we use our sensor node represented by all and other cameras for video acquisition. In the process, here lies the case innovation with perform video processing of the edge, extracting only relevant data, which then stored and processing geospatial database, and output. This structured data feeds our final application from data analysis and statistic dashboard to the generation of spatial intelligence and the creation of digital twins. this system in Mexico don't have or don't existing. And okay, next please. Urban node prototype. This architecture is powered on urban node prototype. As you can see, we have a move from design to real functional prototypes. Each node has a power by display for approx a week of monitoring, and I need a Raspberry board with full connectivity and sensor heads that allows to complement the visual analysis with the key environment data shoots as temperature, humidity, and noise. Next, please. Case studies. The validation of our system is planned for those strategic case studies, the vicinity of CUSEI and the RATs of the Centro Cultural Universitario. These areas with distinct and complex dynamics, we have been chosen to test versatility of our technology. Next, please. And you can see here you can the system in action. This is a capture from our Nodo and CUSEI. The system is detecting and classifying objects in real time, differentiating between cars and people, and keeping a count for each. We can see the exact time of capture and system performance. And the next, please. Similarly, here an example of a node operating a test area. The system identify and count vehicles on a high-speed road. This compatibility for analysis in different contexts demonstrates the robustness and applicability of our platform for smarter traffic management. Okay, thank you.
Well, thank you, Lepe. Just for finishing our presentations, I'm going to talk about these international collaborations. Next, please. Next slide, please. Thank you. So we have already presented here the project that Andres is developing. Andres Rico, you know him, is a PhD student from the Boston lab, and his research focuses on water management and consumption patterns in informal settlements, and he has been called the Project Axel. And it now includes the participation of 6 engineering students from our university, and they are working on an improved version of the sensors, the 2.0 version of water monitoring sensors. And they are now implementing these sensors in the university's rainwater harvesting program, which is called Nubes UDG. And the sensors have been installed in the tanks of 2 facilities, one in a high school and one in the Engineering University Center. And now they have started collecting data from these sources from some months ago. The next steps aim to implement these second generation prototypes in 5 homes in the community of Lomas del Centinela, which was the pilot community, and subsequently in households participating in a government's program, which is called Nidos de Lluvia. It's a similar system that the one that we have implemented in the university. And for this objective, we are doing also a preliminary assessment of these homes. They are located also in marginalized areas. We have conducted 70 surveys with the collaboration also of the government of Jalisco, because this is a state program. Next slide, please. Well, this is a recent collaboration with one of our colleagues from the lab, Juan Rodolfo Alvarez. He's currently doing his PhD in Carnegie Mellon, and actually, well, right now he is in Taipei working with Michael Lin and his team at Taipei Tech, and they are doing, well, he's doing a summer academic residency with the team. And Juan is participated in a project focused on designing a prototype which is capable of navigating in steep terrain. So this is the task that they are trying to implement these regular roads that they have already developed in in Taipei, and that they serve for delivery thing, but now they want to go to this challenge of trying to make this technology working in this type of difficult context, no, in this type of informal settlements, while maintaining or keeping high-speed mobility. So we are also conducting an assessment with the community of Lomas del Centinela. We are going to start with this diagnosis to see how they face this challenge of how do they could relate with a device like this, no, like a delivery robot, and identifying the most relevant needs they have. And the question here, and well, the research question will be like, what will be a useful service that this type of robots could provide to the community, you know, if they can actually serve or figure out some of their basic needs, such as delivering food or yeah, other times, other things like providing or moving the water buckets, or maybe collecting waste in areas that this topography where the traditional vehicles cannot access, no? Next slide, please. Well, next. Yes, thank you. Well, in preparation for the City Science Summit this year, we are collaborating also with the BioBio Lab on the implementation of micro-credentials in vulnerable communities. So the aim is to address the challenge of informal settlements that the BioBio Lab has already introduced. And we hope to contribute with this type of small courses to individuals to develop basic skills and general knowledge that can contribute to these people could growth, and afterwards they could earn some certification that maybe could help also to explore other opportunities in the formal employment market. So together with the BioBio team, we have had some meetings with the team and also with the University of Concepcion to implement an initial course that we have been thinking on a course that could serve the people to develop general concepts. And it's focused on nutrition with some STEM ideas in order that people could have some scientific information on how they could acquire better conditions for their nutrition. So we are proposing a pilot course in in two communities, one in Chile and one in Guadalajara, which is going to be San Juan de Ocotán in Guadalajara. And with the community in Chile is probably that we are going to work with Talcahuano, no? Which is the community they had previous work with them. And that's what we are preparing for, to show you these results and documenting all the process. And hopefully during our meeting next time that we meet in the summit, we can show you the results of this experiment. But we are thinking that this could be a first step of a long-term collaboration with this laboratory. Yes, next. And finally, as we had previously mentioned, since 2023, we have joined the network of urban innovation labs with the Inter-American Development Bank, which is called the Cities Hub. In this community, there are 15 cities, and this network is kind of different in their conception than the one that we have here with the City Science Network, because these laboratories are created within the local governments, no? And they operate with these governmental structures and logic. So the main objective of this network is to strengthen urban and governmental innovation capacities. And to achieve this, the core activities include mentoring or coaching sessions between the different cities, and also mentoring from the IDB with some experts from there, and the exchange of experience and best practices among cities, and also access to support and funding opportunities for our different projects. Well, and only last week we were informed that we will be hosting also this year a boot camp. This is a regular meeting that it had been taken for 2 years before. The first one was in Sao Paulo, the second year was in Medellin, and in this third session we are going to host the team of local leaders from these cities. And for us, it's also a great opportunity to promote and to show them the city science approach with these officials. So I think we are going to ask you also some support. If someone wants to join some of the sessions, we will be glad to have you guys as well. And this focus is mainly on sustainable development and climate resilience. And this event, this bootcamp, is going to take place in September 22nd to 26th in collaboration with the municipality of Guadalajara. So we are working with this local government of Guadalajara. So I think this is, well, the news that we wanted to share with you today. And now we are happy to open the floor for questions and comments that maybe you have. Thank you very much for your attention.
Thank you, Mayra.
Thanks, Mayra. So, first of all, congratulations for the Habitat LATAM conference. I mean, this is exactly the kind of initiative we hope would evolve out of the City Science Network, and we're happy to support that any way we can. And I hope everybody in the network can help make this a success. In fact, I think we're meeting about this shortly, aren't we? And it's also great to see the many collaborations that evolve. UDAHE, BOBO, Type A, MIT. Again, that's exactly the kind of collaboration I hoped would evolve out of the network. And it's good to see you're plugged into this IDB City Hubs initiative. So yeah, I'm sure we can support that in September when that meets. And it's great to see the projects you present. There's lots we could talk about. I guess I have one question because I'm personally interested in this about the urban dynamics detection. You can there are positive urban dynamics like creative interactions, exchange of ideas, vibrancy, playfulness, community building, etc. And then there are negative urban dynamics like crime, violence, drug use, vandalism. How, I guess my question is, how can you recognize and classify all these various types of urban dynamics, both positive and negatively? Are you trying to do that? And if so, can you imagine a next phase where you might identify the interventions that could transform the negative into positive?
Yeah, I would I will take the mic. Yeah, that is an interesting question because there are two different projects in the lab that are trying to use this kind of technology through computer vision. One of them is the analysis of the mobility, the dynamics of people, of students, and the other one is the intersection with the project about safety perception and the identification of the hotspots for the crime. And through the initial research that we have done in the past months, we found that this remains a very open problem, because it is very difficult to know, for example, when two persons are just dancing on the street, or distinguishing that scenario from the scenario in which one person is being kidnapped, for example. No? And we are trying to add some other characteristics that are available through the images, and also to information that comes from other kind of sensors, to try to identify scenarios in which we are in front of a criminal event. For example, if we have a lack of people on the street, and if it's 3 a.m., we do not expect to have people dancing on the street, So we are approaching the problem through that external information, or that additional information that we could have, the light of the scenario, other people that is involved. Also, Lepe is also pushing a project in which we try to identify the feelings of people around the street. For example, if people feel stressed, if people feels happy, that can be a kind of indicator for us to maybe through a machine learning model try to identify if that people is being assaulted, or if it's everything okay. So, but I just wanted to say that this is a very open problem right now. There are some research around the web in which different investigators from around the world are trying to identify that kind of behaviors, but it is not actually done right now.
Okay.
Thank you. I'm actually curious about when we start, or when they start making these models and simulations, what will be the results? Because I think with that information, then we will start having ideas of how we could implement different scenarios and trying to communicate this to the local government, because then we can start working together in a solution in order to transform these negative dynamics into positive, if something is, we can do with this previous information, no? But yeah, and we would like to test I think, the first models in the cultural center, and then we can go to other massive scenarios, and trying to analyze other complex situations. No, but I think Pavel could also rely on this and maybe answer with more accurate or have a more accurate answer regarding this, the purpose and the utility of these tools. Pavel, I don't know if you want to comment something.
Yeah, thank you, Maya. Well, yeah, Lepe has been leading this project, but it came about, and we thought about it when we were collaborating with a mobility lab that we have, a mobility institute that we have here in the University of Guadalajara, and it was very apparent that we needed this automatization of the systems to do the counting of cars and different traffic situations automatically. So very easily and very fastly evolved to trying to use cameras to detect a lot of things, starting with people walking and bicycles in a campus environment, and then we started talking about all the possibilities of detecting, for example, the engagement of a student in a in a classroom, for example, right? So this development, all a new line of investigation within the lab. We are trying to involve a lot of people that we know we could be added to this effort, and I think this will be something that we will be developing in the next years. Really, it's really a very broad area in which we still have more questions that answer, of course, that answers, of course, but that it is evolving very well, and we think we will specialize a little bit on that, and we'll develop a lot of projects. So that's what I would say, Mayra and Kent.
Yeah, I think the point is there are a lot of security companies focused on detecting bad behavior. We should focus on encouraging positive, healthy behavior in urban places.
Yes.
Very interesting idea, Ken. I think we can look into that.
I just wanted to mention also that in this aspect we are collaborating also with Leti at MIT. We have some years trying to to investigate and to find some solutions to the problems of safety perception. So that's another approach that we are pushing in the lab in this collaboration. No? So we also think we can apply that what we found, and we have still need to find in that aspect in order to be applied to design better spaces and safer places in our case.
Marcus, do you wanna?
Yeah, I just have a quick question. In the mobility survey or the mobility data extraction process, it looked like you were looking at vehicles, people, like all these different modalities. Are you which is great. Like, I think that's a big problem in informal communities. There's just very little data on how people are moving around. Is there like a categorization that you're using to say like, okay, just car mobility, or just motorbike, bike, pedestrian? Like, how are you distinguishing between the various mobility modes?
In order to do that, we are not trying to reinvent the wheel. We are using different tools that are available and open source. What we are trying to do is to combine or to use that kind of models to detect, just for example, buses. In the case we are trying to see what is the services that are being the mobility services available in the area, for example, and these kind of models are able to distinguish by themselves that kind of mobility types. No, we have found that in the case of motorcycles, it is a bit more difficult. For example, we have different areas here in Guadalajara where people uses a lot the motorcycles. So sometimes that cases are identified as people moving too fast, but not as a vehicle. No. So yeah, but we are not focusing on differentiating by ourselves, because that is not our objective. We take what has been implemented in order to be used for us, but to solve other kind of problems. For example, the number of people that is attending an event, the number of people that is using some kind of mobility choices, and that kind of questions.
Right. The only reason I was asking is that it could be interesting at one point to validate whatever the outputs are of, for example, bus mobility or, delivery on a motorbike with some kind of ground truth data, so that you could kind of like understand how well your models are doing or how well this data extraction is doing. It might help just think about how to project those into like newer areas that may not have the ground truth data, how to validate.
Yeah, Marcus. I think I think where you're going at, and yes, the idea in the long term is to be able to have the feedback on our systems, so we can reflect what is happening and validate in real time. So yes, we are trying to unify, these concepts that are a little, like umbrella concepts, like digital twins with the Cityscope, probably with vision, artificial vision, so we have the real-time feedback, and we can evaluate what we are trying to simulate. So this kind of, it is related. And going back to your question from my side too, these systems have the ability to basically understand any kind of mobility, people, buses, cycles, and it just depends on the project, the kind of information we are using. And yes, we are working on all. In one of the projects, we are working with cars. In other, we are working with people moving, because it's a campus or whatever. And yes, it has the capabilities of working with all of those. And the idea is to have the positive feedback to our systems in the future.
Great. Nice.
Okay, great. So I think we are right on time. So thank you, Mayra and Sergio and the whole team for your great presentation. A couple of comments. I think Monica shared with everyone the link to the website for the event on August. So if someone wants to share, to look into the agenda and more details, is there. Also, we are having 2 more meetings this week. Tomorrow, Yasushi is he has the PhD dissertation defense, 2:30 p.m. Boston time. Everyone is invited to join online. And then on Thursday at noon, Jordi Astensi from Andorra Lab is presenting. So also everyone is welcome to join. So see you all this week or in the next network meeting in a month or so. Okay, so thank you everyone for coming.
Thank you, everyone.
Thank you, everyone.
Good to see you.
Thank you.
Good to see you guys.
Bye.
Bye. Thank you.
Michael, thank you.